All right, guys, let's look at lesson 1 of unit 5, which is the wave nature of light. So, what does that mean? When we talk about the electronic structure of the atom, so where the electrons are, you must first understand what electromagnetic radiation is. Electromagnetic radiation is a form of wave-like behavior as it travels through space. So what does that mean? That means that waves are a form of matter, and light travels in waves. So characteristics of a wave. So we have the origin in the middle. Then we have the wavelength. The wavelength is the distance that it travels from crest to crest or trough to trough, and the amplitude is the height of the wave. So like we said, the distance between two corresponding points on adjacent waves is the wavelength. The height of the wave between the origin and the crest is the top, or the origin and the trough, which is the bottom, is called the amplitude, so how high the wave is. So, the number of waves that pass a given point per unit of time is called frequency. So this top wave here has a high frequency because there's more waves in this span of time than in the bottom one. The bottom one has a low frequency. So for waves that travel at the same velocity, the longer the wavelength, the smaller the frequency. So this wave at the bottom has a longer wavelength, so it has a shorter frequency. So here's our electromagnetic spectrum. Wavelength increases going to the right, frequency increases going to the left. Us as humans can only see between 400 to 750 nanometers, and that's where the visible region is. But gamma rays, X-rays, ultraviolet, infrared, microwaves, and radio waves are the different types of electromagnetic radiation. Wavelength increases as you go to the right. So radio waves have high frequency, have high wavelength but low frequency. Gamma rays have a low wavelength and a high frequency. So all electromagnetic radiation travels at the same velocity, the speed of light, which is 3.00 times 10 to the 8th meters per second. So we can come up with this equation. This equation is c, which is the speed of light, is equal to the wavelength of the wave times the frequency. So, and again, this equation sets it up so that if your wavelength is large, your frequency will be small. If your frequency is large, your wavelength will be small. So they are indirectly related because when one goes up, the other one goes down. All right, guys, let's look at an example problem. It says calculate the frequency of light if the wavelength is 3.8 times 10 to the minus 7th meters. So the first thing you need to do is you need your equation. So C equals lambda nu. Remember, C is the speed of light, which is a constant. Lambda is the wavelength, needs to be in meters, and frequency is the amount of waves that pass by in a second, and that needs to be in hertz. So we're going to have our speed of light is equal to our wavelength times v, and we're solving for v. So we're going to divide each side by 3.8 times 10 to the minus 7th, and we get our frequency equals 7.89 times 10 to the 14th hertz. Alright guys, let's look at this example problem. Calculate the frequency of light if the wavelength is 650 nanometers. The first thing we need to do is we need to convert. So we're going to set up a conversion t-chart like this, where 650 nanometers times 1 times 10 to the minus 9th, nanometers go away, gives us 6.5 times 10 to the minus 7th meters. Then we're going to plug into our C equals lambda nu equation. So 3.00 times 10 to the 8th equals our wavelength in meters times our frequency. We divide again by our wavelength on both sides and get a frequency of 4.61 times 10 to the 14th hertz. All right, now it's your turn. Let's try a practice problem. Calculate the frequency of light if the wavelength is 500 nanometers. Pause the video, unpause when you're ready. Great, well, what'd you come up with? Well, you should have converted first and have gotten 5.00 times 10 to the minus 7th meters for your wavelength in meters. Then you should have plugged into your equation and you should have divided both sides by 5.00, and you would have gotten your frequency as 6.00 times 10 to the 14th hertz. Now let's try check your understanding. Remember, in order to get credit for your homework, this needs to be done. See you tomorrow.